So now we're going to look at a special kind of operation called a composition of functions. So the composition of functions is when you are using two functions together where you're plugging one function into another function. And the way that it's written is with this open circle. So if we had g with an open circle of f, we could also write that as g of f of x, and that's how you would say that. So if you look at this colored area here, we can see that g of f of x we have, and f of x is the inner function. We always want to start with the inner function, and then we plug it into the outer function. So here we're going to do step 1 first of f of x, and then we'll evaluate or plug in for the g function. So it takes a little bit of getting used to. One thing we do want to make sure that we make note of, this open circle is not a closed circle. So if we have g of f of x like we have there, g of f of x is not the same thing as g times f of x. So a lot of times people get confused between composition and multiplication. If it's a dot and it's not open, you're going to multiply. If it's an open circle, you're doing this composition. So here we have f of g of 3. So we have our two functions f and g. We always want to start with the interior function. So g of 3. So first thing we'll do is g of 3. So we're going to go to our g function and we're going to plug in 3. So 3 squared is going to give us 9. Then we take the answer that we got of 9, because that's g of 3, and we're going to plug that into the f function. So f of 9, we're going to do 2 times 9 minus 3, which is going to give us 18 minus 3, which is 15. Okay, here we have g of f of 3. So interior function first. So f of 3 we're going to do first. In the f function we have 2 times 3 minus 3. So 6 minus 3, which is 3. Then we'll take that 3, because that's our answer for f of 3, and we're going to do g of 3. So this 3 is coming from here, just like this 9 came from there. So g of 3 is going to be 3 squared, which is equal to 9. So our final answer is the second thing that we get, because that's what we got when we plugged in the interior function. So sometimes you'll see something like this where there's numbers to plug in, which is very nice. When it gets a little bit more tricky is when you have to plug in an actual function. So here we have f and we have g, and we want to find f of g of x. Now again, notice it's an open circle, so we're not multiplying, we're just going to use composition. Then we want to state the domain and range. So f of g of x, I like to rewrite it using this notation. So f of g of x. So here, the interior function is g of x, and we're plugging in g of x into f. So in the slide before, we had a number to plug in for x in the g function, but here we don't. So all we're doing is we're keeping everything with x. What I like to do is take the outer function, which is the f function, and write it with blanks in where the x's are. So I have 2x minus 5, so it would be 2 blank minus 5. And in that blank, I'm going to plug the interior function, because what's going to replace x is g of x. So 3x will go in place of the x in the f function. And then this is going to give me 6x minus 5. And if I want to find the domain and range of this, I can try to graph it, because graphing, if possible, is going to be your best bet. So if we graph this, this is a straight line. So a straight line is going to, I'm just going to draw real fast, looks like that. It's going to continue in both directions, both left and right, and up and down. So our domain, I'm just going to use interval notation, is going to be from -infinity to infinity. And our range will also be -infinity to infinity. It doesn't say which notation to use, so I'm just going to use interval notation. Okay, in the second example, again, we have f and we have g, and we want to find g of f of x. So I'm going to rewrite this as g of f of x. And then what I'm going to do is, again, my outer function is g. So that's what I'm going to write So here's my outer function. I'm going to leave a space for where I had x. So everything stays the same in the g function, and we're replacing the x with f of x. So this is going to go in here, negative x plus 1. So because I'm cubing it, this is the same thing as saying negative x plus 1, negative x plus 1, negative x plus 1. There's 3 of them. When you FOIL, you can only FOIL in groups of 2. So what I'm going to do is focus on these 2 and then these 2 to simplify this. So when I FOIL, I'm going to just distribute this 2 here. So this is going to give me negative 2x plus 2. And then I'm going to FOIL this together, which gives me x squared minus 2x plus 1. And then from here, I have to FOIL these 2 together. So I know it seems a little bit annoying, but that's okay. We can do this. So if we FOIL this, we're going to get negative 2x to the third. This is going to give us positive 4x squared. This is going to give us a negative 2x. And then we get positive 2x squared, negative 4x, and positive 2. So when I combine like terms together, I'm going to have negative 2x cubed plus this will become 6x squared, and then this will become negative 6x and plus 2. Oops, there we go. And then the domain and the range. This again, this is going to look something like this, where again the graph is going to extend in both directions, up and down and left and right. So we'll say again in interval notation, domain is negative infinity to infinity, and range is, oops, negative infinity to infinity. Okay, so we're going to look at a couple of applications of composition. So here we have a movie theater charges $8.50 for each of the X tickets sold. The manager wants to determine how much the movie theater gets to keep of their ticket sales if they have to give the studios 75% of the money earned on tickets sales, which we're going to call T of X. If the amount they keep of each ticket sale is K of X, which composition represents the total amount of money the theater gets to keep? So first we want to think about money earned. So at the movie theater, the amount of money that the theater makes in general, that they're earning, is going to be T of X. That's how much money is earned, and that's going to be $8.50 per ticket. So we have $8.50 times X. So X is the number of tickets that we have. Now the theater gets to keep what percentage? Well, we know that the theater has to give 75% of what they earn to the studios. So if the theater is giving 75% away, that means that they're keeping 25% for themselves. So K of X, how much the theater keeps, would be 0.25X. So the total amount of tickets sold times 0.25, so 25% of them. So we can say that, let's just say, for instance, if the theater sells, so we'll just write here, if theater sells $1,000 tickets, 1,000 tickets. So we want to make sense of this before we figure out, are we doing K of T of X or T of K of X? So if the theater sells 1,000 tickets, let's think about how much they earn. Well, they'll earn T of 1,000, because there's 1,000 tickets. So they'll earn $8.50 times 1,000, which is $8,500. If they're giving away 75%, they get to keep 25%. So if they keep 25%, K of the amount of money that they made, $8,500, would be 0.25 times 8,500. Oops, too many zeros. And that's going to equal 2,125. So first we have to figure out how much money is earned, and then we have to figure out how much the theater can keep based off of that. So that means that we're going to have K of T of X, because we care about how much money is earned first, and then the theater can keep a percentage of that. So K of T of X is the composite function that we would be using. Okay, so if we look at one more example, during a sale, a music store is selling all drum kits for 20% off. Preferred customers also receive an additional 15% off. Write a composite function to represent the final cost of a kit for a preferred customer that originally cost C dollars. So first we have to figure out what two functions we're dealing with. So I'm going to call the regular sale f of x, or f of c, sorry. So f of c is going to be how much it costs for everybody. So it's 20% off. So if they're saving 20%, that means they're paying 80%. So the price would be 0.80 times c. So the number of dollars times 80%. That's how much they're paying. And then I'll call G of C the preferred customer. So the preferred customer is getting an additional 15% off. So if they're getting 15% off, that means that they're paying 85%. So that's going to be 0.85C. So we are going to do G of F of C because everyone gets 20% off, and then the preferred customers are getting 15% off of the cost after the original 20%. So well, that'll be G of F of C. So the G function is 0.85 C, so 0.85. But instead of plugging C in, we're going to plug in F of C. So F of C is 0.80 C. So if we simplify this, this is going to give us G of F of C is equal to 0.68 C. So here's our function that we're using. And then for part B, find how much a preferred customer would have to pay to buy a drum kit that originally cost $248. Evaluate the composite function for C equals 248. So now we're just going to use the composite function we wrote in part A, and we're going to say G of F of 248. So we could do F of 248 and then plug that into G, but because we already made the composite function, we can just plug it right into here. So we'll say 0.68 times C, which is 248. And when we solve this, we'll end up getting $168.64.